Hello and welcome to Func Prog Sweden. My name is Magnus and I'm the host at Func Prog. Func Prog Sweden is the meetup for you that is interested in functional programming. And throughout the different meetups, we have explored functional programming languages such as Erlang, Elixir, Scala, F#, Elixir, and Clojure. We have also endeavored into other areas like C++ for functional programming, Java, C#, and also JavaScript. And today we're gonna go into functional programming in a database and also functional programming in an operating system. With that said, we'll go over to the agenda of today. So this is the agenda. First up, it's me. I'm doing a short intro. And then we head over to Marek and Datomic, a scalable, immutable database system by. And then we're going to look into macOS to NixOS, the purely functional Linux distribution by Daniel Britten. And in the end, we'll do a short schedule and summary. First, I would like to thank Avid as the video sponsor. Avid is a consultancy company based in Stockholm, but also have an office in Ho Chi Minh in Vietnam. Most of the developers in Avid have a functional programming background, and if you want to know more about Avid, head over to avid.com or check them out in social media. Oh, wrong way. No, right way. If you want to support the meetup, and of course you want to do that, head over to the meetup community and join there. And remember to follow us here on YouTube also, in the YouTube channel. And if you like, you can also check out the merchandise store at funcprogsweden.myspreadshop.net, where you can get a Func Prog Sweden t-shirt, if you like. If you have questions during the presentations or thoughts, input, please use the chat and ask the questions and I will read them up for the presenters. With that said, let's get started. We'll have our first presenter with us. Marek, welcome to Func Prog Sweden.
Welcome, Magnus. Thank you very much for the invitation.
Yeah, you're welcome. And you're coming with us all the way from New Zealand. So you're already ahead of time of us, 12 hours ahead.
Yes, that is true. I'm 12 hours from Central Europe, so it's early morning here.
How's the future? Is it good?
It looks fine. It looks fine. The sun is up, and also the future is the summer, because we have summer now on the southern hemisphere. Yes. So you will enjoy the summer in half a year. It's awesome.
Great. Warm welcome. And let's get started.
All right. So my name is Marek Lipert, and good evening, everyone. Good evening. I am a CTO of Spinny. Spinny is a company that produces various kinds of software. It is based in Kraków in Poland. And we are trying to incorporate as much Clojure into Spinny as possible. And we are also using Datomic in production systems. So I can not only talk about Datomic, but maybe if there are questions after the presentation, I can talk a little bit about what we do in Spinny with it. So today I will be talking about, as was already introduced by Magnus, about Datomic. Datomic is a database that is based on functional principles, mostly the immutability. It was built by Rich Hickey, the same person that has created Clojure programming language. And it builds on Clojure foundations, although it is not only accessible from Clojure. People can use various programming languages to interact with Datomic, but the most natural way is through Clojure. So Rich has built Clojure because he thought that writing stuff in Java, which was one of the languages that he mostly used, was a little bit tedious and not productive. So he thought about introducing some Lisp principles into Java. He basically built Lisp on top of JVM with all the advantages of simple, clean syntax. And he added a lot of data structures. And also he knew that in order to introduce a new language into the ecosystem, you have to, now in 2022, or it was 2010 when he introduced it, but it's also valid now, you have to have a base of libraries. You can't just come out of blue and say, this is my new language, because people want to leverage what was already built over the years. So this was his choice of JVM. And now one of the cornerstones of Clojure and the actual research project that he undertook in order to develop understanding whether it is viable or not was immutable data structures. So he built those immutable data structures to be performant, and he didn't know will it work on JVM or not. And he got some scientific papers, he put them in, and to his surprise, it worked. So this was the foundation of Clojure, and it is not surprising to see that he used the same principle to build a database system. So for all of you who know Clojure, those 2 minutes might be very boring, but I just wanted to quickly introduce the language, which is very simple, so that, because I will be using some of the code examples later on. So in Clojure, everything is a list, and as in every Lisp. And those Lisps are interpreted by the compiler most of the time as function invocation. So in here you have an invocation of minus with 7 and 1, and then multiplication with 2, and the result of this minus 7 and 1, and so on. So the arithmetic looks a little bit odd, but it's very, it's a very fast process to get used to it. Now, this is the syntax for lambdas. So lambdas are created with fn form, and you can see that there's an argument, a vector, and then the body of a function, of course, no return. So it allows to produce very concise code, like, for example, using just the star operator as the name of a function in reduction is possible because of this syntax. Most languages would not allow you to just put just a star operator as a multiplication function. Now there's also therefore basic data structures. So there's vectors, there's lists. This list has to be quoted because lists by default are interpreted as function calls, and we don't want to call 1 on 2 and 3. There are sets, and of course there are associative maps. Forgive me. And all those data structures are immutable. So yeah, this is the data structure access. So we can just use keywords as functions to extract stuff from maps, for example. This is the function definition. So it's very similar to Lambda definition, but it defines the function as a symbol in a local namespace. And this is how we write recursive functions. So there can be 2 different argument sets. So you see that the function has different form depending on how many arguments are used, 2 or 3. And the recur form, the recur form allows us to, go back recursively, and it also ensures that the tail recursion optimizations are being employed in here. Yes, so we can just use this function and observe the result. Yes, I think that's all about Clojure. And now the demo of this immutability. So when we have like a map that's called zoo, we can do an ASOC in, which means that we go to the element of elephant habits and the second entry, and we could just add this entry, the sleeping entry into it. That's, by the way, that's also very concise and interesting syntax. I had the pleasure to attend a meeting that was on the meeting, the speaker was explaining a library that they wrote for JavaScript to allow similar functionality. But in Clojure, it's built in, and as you see, the data structures, they share memory with each other. So even though we do this ASOC in, the zoo is still the same as it was, and it's all performant, and it's occupying memory only once. Okay, so let us move on to the database design. So our database, since I currently live in New Zealand, the database will be based around animals. And I also used to consult with a company that was doing a lot with animals. So this is a very good topic for me. So let's say that we're talking about those animals and we have certain fields in the database, right? So there's this cow. The EID tag is something that they have in their ear and can be read by a special stick. And this is like a unique number of an animal. And they use this in all the farm management software. Okay. And now most of the database systems would, when you, for example, change something in the data row, they would say, okay, so now this cow has age 16 months, probably. And we take this for granted. But when we think about it, it's not as obvious. Like, first of all, is the cow during the next month the same animal as it was in the former month? Like, one could say, yes, obviously it's the same cow, but the time flows, the cow could develop, I don't know, like a little bit more muscle, or it could become sick. And it may not be the exactly same cow. So this is more like a philosophical question. But in Datomic, this question is at the core of what we do. And when you look at the past, when people kept records in the past using paper, like, for example, ancient Egypt, they would never be able to replace some variables in their notes, right? They would always add new notes because, they would keep all the former records for audit, for inspection. So in some ways, it's very natural to think about those things as, different things. It might be, not exactly the same cow. Yes, so this is a demonstration of another change in a normal database, so that the original values are lost again. So the weight was increased and it's just gone. We see the new weight, but we don't have the foggiest idea what was the weight in the past. And now the question is, well, are those the same animals now? Because, the species has changed, the sex has changed, but the EID tag remained the same. And this also happens people tend to reuse EID tags. And obviously, if we base our data rows in the database on this EID tag, then we have a lot of problems, because suddenly, you know, in our system, this animal has changed its species, and maybe this is not something we want to have in the system, right? So I brought those examples here to demonstrate that thinking about the state in a way that it is as it is now, and we don't think about what it was in the past, might not be the most accurate approach in various applications. So Datomic works as a system that just takes notes. So this is an entry from, let's say, Datomic database. And you see that it does not change anything. It just stores new facts. So some people say like Datomic is the data store for facts, not for objects, because you see that there's no object in here. There's only facts, and there is this entity number that's displayed in here, but this only means that those facts are associated with a certain entity, but they can change the species, and you can see it all. And they are ordered according to the time they were installed. So the time flow in the database is a time of subsequent transactions. Yes, so I will show this example in code. So we use Datomic, and now we do a transaction which just adds certain information into the database. And then later on, we can do a different transaction that modifies the object, not modifies the object, but adds additional facts throughout the database. Each line of the transaction is called a datum. So you see that it's a vector that contains other vectors. So this is the form that the Datomic accepts its inputs. So it's the operation name, the entity number, then the field that we want to modify, and the new value. Okay. And yeah, the third one changes the species, right? So this is the third operation. So, so it's a summary of this section. So as humans, we used to write and accumulate our records. Never did we modify them. In ancient times, and also in a lot of paperwork we do, we only accumulate facts. And computers give us the ability to see the state of the system at any point in time. So this is something new that the ancient Egyptians didn't have. So we can, in Datomic, we have access to this illusion that the system works as an ordinary SQL database, but this illusion is for reading only, and we can view the current state. But this system also allows us to travel in time and to say, for example, that we want to see the whole system as it was 3 weeks ago. And then we pass we pass the date variable to the database creation, let's say database creation code. And then suddenly we can see everything as it was in the past. So I think I don't have to tell you how useful this can be during debugging, because you can go through all the events that happened in the database, one by one. You can even log metadata. So for example, in our system, we log the request, the IP address the request was from, on the backend system. And then we can understand in full glory what was happening and when. Okay, so the next step, I will show you how you describe the database schema in Datomic. So another interesting feature is that there's no division into tables. So you can think about Datomic as a single table, and certain rows might have certain attributes, but at any time you can add or remove entries according to your needs. So for example, when we we can create those, let's say, the DB ident. It means that we are creating a possible field for the database. So for example, this ear tag EID, right? And now the prefix doesn't matter, it's just for organizing data. So we can think of this as helping us out. And it can have things like animal, for example, just to associate them with animal, but there's nothing stopping us from giving animal / for example, weight to a car that we have in the system, right? So this has to be designed very wisely. And of course, it wouldn't be the best practice to give an attribute called animal.weight to a car, right? We would rather have something like, I don't know, general attributes / weight, and then we could associate it with different things. So this flexibility, you know, it sometimes freaks people out, but I really enjoy it because, you know, you can add some attributes later on and not be worried that you have to go through some kind of migration or some, you know, modification of the table. And you're also not worried that in the table, for example, tons of animals can have all those fields that are listed in here, but there could be one animal that has one additional field, only one animal, right? And then you don't want to create a separate column to just store this one additional fact for a single animal, right? And by the way, the schema is also a set of datums. Those datums in here, this is like an alternative way to write datums because it used to be a vector in the past, but now it's written as a map, but it doesn't matter, it still works. So it stores those facts as any other facts. So in some ways, the schema is contained within it. And those entities, as I say, they can be modified. So we can add additional things in here, like farm names, paddocks, and combine them in whatever way we want. And now this is an example of a more advanced schema. So we can have some relationships, right? So there could be a paddock inside of which the animals reside. And we could associate animals with paddocks as it is visible on the bottom of the second slide. Now I'll present you the query language. So this is an equivalent to SQL select statement. And it is constructed so that it's a data structure within Clojure. So you see that there is a vector in the query form, and this vector tells us what do we want to get, right? Then it tells us that this in can accept parameters from outside. So the only parameter here is the database snapshot. So it shows at the very bottom as an argument to the function. And then inside the where block, we're just listing the requirements that we want. So we want the animal to have certain temperature. We want the animals, we want to extract the age, right? So this is also something that we write. And by combining those forms, we can arrive at the query. The queries can be more complex, like they can include or and forms, but this is the basic idea of how we query in Datomic. So this is an example of what I was saying. So when we go back in time to the time that where we had no paddocks, then this query will not return anything because there was no such facts accumulated in the database at that time, right? And we can also see that this animal and age are as they were before. So in this way, we can see the past. So you see that, yeah, this compares with the table. So when we have the date set at 2021, so this first transaction, the subsequent facts are not visible. So only the facts that are marked in blue are visible to the system, and that's why the response is as it is. Okay, so now we'll be talking about the design of the very system. So Datomic selects a systems approach to not reinvent the wheel, and storage is separate and uses existing solutions. So for example, in our company, we're using DynamoDB for storage, and you can think of Datomic as just like a program that works on top of it, does a lot of caching. The unique thing about this database is that Rich has chosen it to be sequential. So there's only one, let's say, process that is allowed to write at one time. So there's something we call transactor. All the clients are connected with a transactor, and when somebody submits a transaction to a transactor, the transactor will not process any subsequent transactions until this one is done. So this way we can keep sane with writing, and so writing doesn't scale. But when it comes to reading, we can scale however much we like, and we can use some caching software, like for example, Memcached, to allow for even quicker read access. And since we have a single transactor, the full ACID is ensured. So this is similar to an SQL database, that we have certainty that if we write something, it's actually written to the database. Yes, so query, transaction, and coordination and storage are separate services. When it comes to queries, so the funny thing is that when you are using Datomic on premise, you can have the query engine that is embedded into the application you write, which means that in some ways, this library is like a database that is being run on your local machine or on your server. So this means that there's no latency between the database and the application because they're in the same, let's say, JVM. They reside in the same JVM. Yes, and there's also an option to use SQL or Cassandra as an external storage. We've chosen DynamoDB because of its other properties. I will not go deeper into this for now. Yeah, and as I said, it's ACID for writes, high availability and scalability for reads because of immutability. So you can read from various versions of this database, and it's all fast. Now, when it comes to partition tolerance, in CAP theorem, we have C and P, which means that if transactor is not available, we can't access the database. So, but transactors can be run in pairs, so that whenever one of them goes down, the other one takes over. So this mitigates this problem. But in this theorem, CAP theorem, you can only select two letters. So that's what they've selected. And now I'll talk a bit about the architecture. So write performance is dependent on the single transactor. You can see the transactor in bottom left corner. And the transactor is also responsible for writing to the storage. So the write throughput would be similar to a standalone SQL server. But because of immutability, read operations can be parallelized and aggressively cached. So this allows a lot of scaling for the reading. And now there's two possible architectures, you see. One that we use in Spinning on the left. This is where the peer library is integrated with your app inside JVM. And there's also another architecture possible when you have something called peer server, which does all the caching and it acts like a front end of the database. So it allows other clients from other languages to connect over HTTP and get information as from a normal database. And this means that if you use the architecture on the left, there's no n+1 query problem because there's no latency. You can do queries however you like, in however sequence you like. And since everything is very aggressively cached, most of your queries would result in something almost immediately. And you can divide your query, or you can do a one big query. It doesn't matter that much as it does in SQL databases where the latency could kill you. And if you're doing a million of small queries, it could be way, way slower than a single query that extracts a million lines, right? Yes. So again, the primary components are the storage services, transactor, peer library, peer server for this, let's say, right-wing architecture, and client library, which is available in various languages. Now the sour part. So unfortunately, Datomic is not for free. They've built this system in order to apparently, sell it. So the licensing goes like this. There's a viable free version, and there's also a pro version that is being licensed to you for free, but it has no support and it has access to updates only for 1 year. And after this, if you want to use the on-premise version, you need to buy a license if you want to get the updates and support. And the other solution is to use Datomic Cloud, which is just some added per hour cost on AWS. So I think the team on Datomic, they've been putting a lot of effort into this option throughout the last few years. And I think this is the preferred option now because it's so easy to build, you just pay a little bit more for your EC2 instance and you get all the benefits of this system. All right, so I think this is all I wanted to say. Thank you very much for your attention. Are there any questions?
Yes, thank you very much, Marek. Thank you very much for your presentation. Thank you. Yes, we actually have one question. One question is, could you elaborate a bit what's the difference between the Datomic and a normal relationship database? I mean, what's the pros of using a Datomic database instead of?
Thank you. Yes. So the biggest advantage of Datomic over the normal relationship database is the fact that we store all the history, and this history doesn't get lost. So, for example, when you change something in a normal relational database, you have no access to the information of what this field was before. Like I spoke about the age of the cow. So when we change in normal relationship database, when we've had this cow, just quickly go through it. So when we change the age of the cow, the information that the age was 15 in the past is lost. And what is being given to us by Datomic is the access to this lost information. So we can traverse the database even in a way that we can go and say, give me all the events that happened to this animal or to this entity, whatever it is. And Datomic would give us all the transactions that have ever modified this entity in any way. And thanks to this, we can do a lot of stuff. So it's only up to your imagination to figure out how to use this functionality. We use it mostly for bug detection and fixing, and also for reproducing some strange scenarios that happened in the past. But you can also use it to query the database. For example, imagine we've been in a situation when we wrote an application that is similar to Uber Eats. So it's a delivery application that allows you to deliver food. And now we had this problem that, when somebody, imagine one person editing some food, like changing price of food, and another person that has already ordered the food, right? So you don't want the food to change in the middle of the process. You don't want the, like, let's say that somebody has edited, not the price, but sorry, let's say that they've edited that it's with ketchup now, right? With ketchup now. And you don't want the person that ordered a food that doesn't have ketchup to be given a food with ketchup if a manager edits this line. So you have to keep all the versions of the food together, because there might be still people that have ordered the past versions of food. And Datomic solves this problem very beautifully, because you just remember the time at which something was ordered, and you access the database as it was when the thing was ordered, when you cook it. So that's one example where it helps. And now it is not true that SQL doesn't have this functionality. You can build this functionality into SQL by, creating a new row for every entry, but not many people do this. And this is also quite taxing on the database. So SQL databases are not prepared to be, let's say, a store of facts. They're rather tailored at being store of values.
Yep. How do you see, when you do that, I mean, I assume you like, it's kind of if people are interested, you can go into look into event sourcing. It's kind of the principle here. Would you agree on that? That you event source, that you never forget anything, that you just add, like a ledger?
Yes, exactly.
Yeah. How would you see data growth? Because you will eventually, you will. Have you seen issues with data growth, or is that, no, we haven't seen? I mean, we buy more space in the cloud, and who cares?
No, so how Datomic is built, it has certain limits on the size of the data that can be there. So Cognitech, which manufactures Datomic, they say that it can easily work up until 10 billion of data. So 10 billion of facts to be stored, but you can create shards within the database to alleviate this problem. You can have different, let's say, sets of information that sit in the database. But because of how they've structured in the indices, that's how it is. So obviously we haven't encountered this problem, because in our products, we don't store like this much data. But what Rich always says is that, not every database is for every job. So
True.
Datomic is not something that should be used, for example, to store log files, right? And you could say the same about SQL databases. The databases that offer you more functionality are better employed to store, for example, financial information, information that is valuable for the company and that you want to ensure its correctness. Whereas, for example, if you were to store log files or some millions of lines of some, random streams coming from Internet of Things devices, you would rather use a normal NoSQL database, like, for example, Raw Dynamo, or I don't know, Mongo or CouchDB. So it's not for every for every use case. It's for a use case that is more like tailored at safety and full ACID capability.
Got one more question. Like, how suitable is it for real-time capabilities around?
Okay, so since it's based on Java, right, so on JVM, and it's the Clojure as a language it was written in is also a high-level language. It means that it uses garbage collection. So I would say that as far as this is not a problem, then it can be used in real-time systems, but I would hesitate, because, in real-time systems, you want to have full control over what's happening, and you can't allow garbage collector to run in random times, right? So I would say it's not suitable for real-time systems. For real-time systems, the database written in low-level language would need to be employed, like in Rust or in C.
Yes. Let's see if we have more questions. Is there a Docker version of Datomic?
So we've built Docker containers ourselves, but So it is not easy for me to say. I've never researched like pre-made Docker containers for it. We were based on just on like simple Java JVM containers, and then we add Datomic from there on.
Yeah.
But yeah, so sorry, I can't answer this question, but I think it's easily Googleable.
Yeah, it should be. Okay, so the question was like, yeah, the question is like real-time. Let's put it like this: does Datomic have any mechanism to notify about changes happening in the database?
Yes, so there is, and by default, all the peer libraries are directly connected to Transactor. So in the background, Transactor notifies everyone who's attached to the system about the changes.
Okay. Great. I don't see any more questions. Thanks again, Marek, for your very nice presentation. It was very good. Thank you very much.
Thank you very much, and thank you for the invitation again.
Oh, you're welcome. You're welcome. Thank you very much. Yes, then we'll head over to our next presenter, Daniel. Welcome, Daniel, and welcome to Func Prog Sweden.
Hi there. Yeah, thank you for having me.
You're welcome. You're also, I will say good morning to you, as you're also sitting in New Zealand.
Yes, yeah, it's the morning here, so morning sun. Yeah.
Nice. So head over to, yeah, thanks.
Yeah, so hi. So thanks again for having me at this meetup. Yeah, just like Marek, I'm here starting my day in New Zealand, and yeah, we actually both often or sometimes attend the functional programming meetup here in Auckland. My background is that I'm a PhD student at the University of Waikato with a research focus on using theorem proving to guarantee the correctness and security properties of blockchain smart contracts. And I'm interested in functional languages in general, especially dependently typed languages. But today I'll be talking about the relatively lighter topic of switching from macOS to NixOS, which is a Linux distribution that has won the hearts of many. NixOS, the so-called purely functional Linux distribution, it's an interesting choice to switch to from macOS or any OS. It has some unique advantages, as well as some annoying quirks. And I'll discuss my experience of switching from a MacBook Pro to a Dell, running NixOS for my everyday usage as a computer science PhD student. And I'll also share some thoughts from fellow NixOS users. In my PhD, I work proving properties modeled in a functional language. And the fact that it's a functional language makes them easier to reason about. And similarly, I'd say a NixOS system is easier to reason about due to it being configured entirely declaratively. In terms of operating systems, I used Windows for 4 years of university plus beforehand. I've used macOS I used it for about 1.5 years as a PhD student, and I've used NixOS for just over a year so far. And before using NixOS, I hadn't ever used a Linux distribution as my daily driver before, but I had like dabbled. And so I'll briefly go over why I switched. So I began to use the package manager Nix. So NixOS is an operating system built around this package manager, but the package manager itself can be used on macOS or other Linux distributions as well. And I was curious about using Linux as a day-to-day operating system, but I wasn't particularly myself impressed with Ubuntu, Arch, or anything else, as they seemed likely to become tricky to manage if I was trying out different programs, configurations, and setups to make it work for me. I thought those Linux distributions, just like Windows and Mac, would kind of get messy, and my MacBook had gotten messy in the sense that there was a lot on there, like old Haskell stack versions and things that I didn't use anymore, but didn't quite have the time to figure out how best to uninstall. And NixOS offered a unique solution here. All my programs and system configuration can be defined in a text file or two with the ability to easily experiment and roll back if need be. Ideal, I thought. And then the most practical reason for myself was that my personal MacBook had only 256 gigs of storage, and I was running short of space. And my university provided me with a new laptop with more storage, and they were willing to let me install any operating system I liked. So I made the switch. So just a brief overview of NixOS. So on the screen, there's a screenshot of like a small snippet of what's called the NixStore, and also like the grub boot menu. And so Nix is like the purely functional package manager, and NixOS, as I mentioned, is built around this. So it treats packages like values in a purely functional programming language. And these are built by functions that are side effect free, and they never change once built. So packages are stored in the NixStore. So like on the screen, you can see like text live, some text live package is there. And each package's directory name has a hash, begins with a hash of the package's build dependency graph. And this approach results in at least the following benefits. So multiple versions of software can easily coexist, in part because they've got different hashes, and so they end up being at different paths. Dependencies are always complete, so this helps really aiding reproducibility on other machines that are running Nix. You have atomic upgrades and rollbacks. So anytime you upgrade something, it's always possible to just roll back and revert to the previous setup. The package language is a functional language, which is nice. And the garbage collection is so kind of, it separates uninstalling a package from actually deleting it. So you can uninstall a package, and then once there's no references to that package anymore, then you can garbage collect all of them away. And I might mention more on that later. And also, like, this isn't relevant for me, but multi-user support is quite useful sometimes. It's possible for non-privileged users to basically install packages without interfering with other users. So that can be useful in some contexts. And I'll just also mention, so every time you upgrade your system, it generates a new generation. So on the slide, that's what the list of generations is. And so you can always, assuming you haven't garbage collected, you can roll back to any previous generation, which is very useful when doing upgrades and not worrying about breaking something. You might also notice that I have Windows Boot Manager up there. So I have found it helpful to dual boot for certain Windows specific things. So here are a few key advantages I personally felt the benefit of. So firstly, I mentioned the atomic upgrades and rollback. So this results in a really overall stable system. When updating, you can always roll back if you don't like the changes. And I think this is pretty common to NixOS, the updating while working. Sorry, common to Linux in general, but especially on NixOS because of the way that past versions don't interfere with future versions. It's very easy to just upgrade your system and then reboot like almost as fast as normal. It's really easy to safely experiment. I've experimented with the kernel and different things that I normally might have been a lot more hesitant to because I wasn't sure that I would not break something, but simply because I know I can roll back, I am able to tinker with parts of the system that I might not otherwise have had the courage to. You learn more Nix along the way. So normally when you are configuring, I don't know, your DNS or just some other setting on your system, it's using something kind of like specific, like maybe even a GUI or just some kind of configuration file that's very unique to that specific scenario. Whereas with Nix, pretty much everything you do configuration-wise and installing software is in Nix. So you always are learning and upskilling your Nix as you do literally anything. And so this really helps increase your skill set. And this skill set is useful for everything from making developer environments to setting up servers as well that are running NixOS as well. And the declarative aspect of NixOS is, well, so if things break, they always break in the same way, and they can be fixed in the same way. So there's no more, this works on my machine, because if you're on the same Nix channel and have essentially the same config, things will either work identically or fail identically, which is kind of helpful, because even if something fails, when someone posts a fix that is applicable to your situation, it will work. And so that's quite useful as well. And it's kind of fun to be using an operating system with a unique paradigm that has some of these unique advantages. And so, yeah, I encourage you to try it and see. There are ways to try it without kind of, reinstalling your operating system. You can try it on AWS. You can try it on a virtual machine as well, or you can just try the Nix package manager on any Linux or Mac OS. So some annoying quirks that I've come across. So the first one that always comes to my mind is that that should be /bin/bash, but yeah. So bin bash is not always there by default, and this can cause annoying issues with scripts and things like with shebangs that rely on bin bash in particular and haven't been patched. But there are workarounds, and my Wi-Fi occasionally drops. My sleep on my laptop doesn't behave well, so I now use Hibernate mostly. Zoom screen sharing, this is probably typical of Linux in general, but it only works properly on the XOR system, not Wayland. But I don't know, you get used to these things. And occasionally executables will just kind of work fine, say on Ubuntu, but not on NixOS. And so you have to get used to a little bit of friction sometimes. Yeah, and when software says oh, do you want to update? The update prompts don't really work because you have to always update through NixOS. There are some exceptions to this, for example, I don't know, Discord will update itself, but it does depend on the situation. So those are some quirks I've found. I thought I'd also just mention some packages that I've found useful coming from macOS to Linux. So this slide has a few examples of that. And yeah, macOS, obviously the integration you get between, say, an iPhone, iPad, and MacBook is never going to be quite matched on any Linux distribution. But I think our brains get pretty adaptive at getting used to workarounds and alternatives. And yeah, web apps are particularly useful. So much good software is just a web app. For example, Crypty, TickTick, and Google Docs on this slide. And this presentation itself is Google Slides. And yeah, you can make web shortcuts that make it feel like an app anyway. So yeah, just thought I would mention some of these, and pretty much all the content in these slides is also in notes at the end if you are interested. A couple of memes. So the one on the left I got from a blog from Replit. So Replit is an online collaborative browser-based IDE, if you haven't heard of it. And they've, as they put it, jumped on the Nix train. And so you can now run all sorts of languages through their browser-based IDE, and that's powered by Nix. And yeah, they mentioned how this it worked on my machine and how Nix really helps solve that problem. Another one is on the right from the NixOS subreddit, is just poking fun at how the rollbacks are really helpful on NixOS. Yeah, so and there's plenty of interesting memes if you Google NixOS memes. I will admit a lot of them are more negative, like those ones that kind of poke fun at how Nix can be a big learning curve sometimes for people. So yeah, that's also part of what people have made memes about. Yeah, and then I wanted to mention as well, so I put a question out a few days ago of just asking the NixOS community what the highlights of daily driving NixOS are. on the NixOS forum. And so these are a few highlights I wanted to share, but also feel free to check out the discussion later via the link I'll share. There's some good thoughts there. So one thing that I mentioned earlier about developer environments is, so Nix shell. So this is one of the kind of most practically useful things for developers. And so as with everything on Nix, it's defined by the functional language Nix. And so these shell environments can be used on macOS as well, but also any Linux distro. And basically it defines your set of dependencies, and then you just type Nix shell, so in your specific directory, and it will load all of those dependencies into like interactive bash prompt. And so you can use this to set up all your dependencies for a project, and then you can share this shell.nix file with other people. And when they run it on their machine, they'll have the developer environment just like you. And there's also a lot of, like, it doesn't waste space. So if you have, your Nix shell and you have a similar project in a different directory, then you can, it'll share all of the content in the Nix store. So basically it'll install all those programs and make them available within that directory. And so I've used this, for example, I used to work on a project for my PhD. The proof system I use is based around OCaml, and I used to like mess around with OPAM and the switches, and I was finding it quite frustrating when I wanted to switch versions and things like that. And so eventually I switched to using Nix shell for that, and completely replaced OPAM in my workflow. And I found it really beneficial. The user experience was a lot smoother. And I was also then able to, without much effort, automate things like when I was setting up continuous integration, I could just use the same shell.nix to run the tests on GitHub or Travis. So that's really neat. And then, so in terms of reproducibility, this really helps with solving the it works on my machine problem. So basically this is because every dependency is pinned down to a specific version, like and typically there's a hash of the either binary or it's just built from source. And when it's built from source, it's usually cached. So you have the NixOS kind of cache that is online, and you can also enable like custom binary caches as well for your specific team, or like using other people's like projects. And so yeah, this together with Nix shell makes reproducibility really easy for developer environments and building anything. So these are some of the things that were mentioned by other NixOS users. The most common thing mentioned was it's highly recommended to start out with Nix on macOS or Linux first. This is partly because once you switch to NixOS, you kind of can only do things the right way. And so that means that when you are on NixOS and you want to do something like, I don't know, installing a graphics driver, you have to do it through the configuration.nix file, and you have to kind of know how or learn how. So if you want to just get a feel and get a bit of familiarity before switching, then it's, yeah, multiple people recommended starting out with Nix, the package manager alone first. And this was my journey as well. I started with Nix on macOS originally. It's really nice that the entire system state is in Git. I mean, it doesn't have to be, but it usually is. And so, yeah, just every small configuration change you make to your entire system has comments and a commit history, which is really, really helpful when you're trying to work out why you did something like 6 months ago. And yeah, there's no urges to completely reinstall the OS to get out of the mess. So this happened to me a lot like when I was on Windows and macOS, I would find myself maybe every 6 months, a year, being like, oh, like there's too much random stuff that I can't find or uninstall. I'm just going to reinstall the operating system and start fresh. Whereas with NixOS, you always have a very clear idea of what's on your system. And if you want to change and delete things, it's very, very easy and clear to do that. So yeah, this is my own experience, but it's also from someone else who commented on how, yeah, you feel that there's no need to reinstall the operating system. And a couple more. So with Nix on macOS, yeah, this is for someone who doesn't use NixOS but does use Nix. You're able to manage like everything from even apparently homebrew file like installs to DNS to all sorts of system configuration. And so you can go quite far without even installing NixOS in terms of getting the benefits of the kind of declarative way of managing your system. Yeah, many people mentioned that NixOS requires learning of the functional language Nix. And yeah, it does, and it also doesn't. Like a lot of this stuff is very kind of straightforward, but it is a like full-on functional language, so you can go quite far with that. But a lot of the time, it's like you don't need to know too much, to be honest. But it does help. Yeah, some people describe NixOS as indestructible. This is referring to like rollbacks and being able to revert to a previous system state. Yeah, interestingly, I see a parallel here between how in Datomic you can like go back to a like view the database from any point in time. On NixOS, you can basically roll back a system to pretty much any point in time if you want to, which is quite useful. And yeah, it's also a really easy way of showing div environments, assuming the other person's using Nix, but still, like it's definitely very highly likely that you'll get a reproducible development environment set up. And so yeah, so that's some of the benefits there. Yeah. So I wanted to give a brief just demonstration of just the feel of NixOS, and also look at a couple of small code examples. So I guess the first thing I'll mention is that this is GNOME. So I assume you can see. Yeah, you can see. So NixOS works with GNOME as well as KDE. So these are different desktop desktop managers, if you're not aware of them. So like, and the experience is very fluid, I guess is my main point here, is that this is kind of like Mac, but you can also alt tab in like different ways. And so it's pretty nice. You can run all your favorite programs like VS Code and so on, except the like 2 proprietary Windows and Mac specific ones. But yeah, and then so this here is my home.nix file. So this kind of defines all of the programs on my system. And so as you can see, I've got random comments about all sorts of different things that I wouldn't say this is a particularly clean home.nix file, but I'm just giving you a real world example. So this is the Nix language as well. So everything that ends with .nix is going to be the Nix language. And so we have like, you can't quite see the other side of this bracket, but there's a list. So we have lists, we have if statements, although I don't think there's any in this file. And you can do things like have Python packages installed, and you can override packages as well. This is quite neat. So I've got Firefox here and I've overridden it so that it works better with my touchscreen. And this just gives you a brief idea. And like, so if I wanted to uninstall Chromium, for example, I would simply delete it from this file. and then I would type, well, in my case, I've got a little script for it, but I would just type .rebuild, and all rebuild does is call home manager to like rebuild it. So these are like fine details, but the idea is that like to uninstall something, you just delete it rather than like kind of actively uninstall it. You just redefine the system state and then reload that state. Yeah, and so that's quite practically useful. And all of these here are defined by pinned back to a specific version. And in my system, this is pinned back to what's called the Nix channel, but there's a newer version which is called Nix Flakes, which has kind of this notion of everything being pinned down within your Nix files to a specific version, even more precisely than what I have here. So this gives some understanding of the Nix system. You can also configure like settings as well. So here, for example, I have the default applications to open different types of documents. And so there's a lot you can configure. It's not just programs, but it's also yeah, things in your home directory and like dot files and so on. So yeah, so that's all possible with Nix. And then in terms of NixOS, so the main file so that's kind of what I just showed you there. You can do all of that on Linux or Mac. What I'm showing you here is more specific to NixOS, where you're actually kind of controlling the operating system itself. So in the configuration.nix files, where you define how the system is configured as a whole, and you can put programs in this file, but you don't have to. So and every time you update this file, that's what generates the generations from in the boot menu, which is kind of unique as well. I do want to highlight that. So like typically when you have a installation, you have say dual boot, you've got your Linux install, your Windows install. So on NixOS you have like literally hundreds of potentially of generations of NixOS, and they're all bootable. And then you also might have your Windows install, and maybe if you want an Ubuntu as well or something. So yeah, so that's quite neat. And so like here you can see that I have to like enable OpenGL 32-bit, and this is so that I could try run Steam. And by the way, this is part of the reason why I installed Windows. But yeah, so it is possible to run games on NixOS. It is, but nowhere near as nicely as Windows, of course. But yeah, like I did also experiment with virtualization. So you can use Docker, you can use VirtualBox, and these things work pretty smoothly, as you would imagine. And yeah, so that's kind of how long the file is. So it's not terribly long. Yeah, so I just thought I would just mention those things. I will also highlight, this is, so recently I deleted a lot of my old generations because they take up a lot of storage space, as you might imagine. And so when you have these generations of your operating system, it's kind of like updating a operating system, but keeping all of the files needed for the old one, right? And so it takes up a lot of space. And I freed up like 150 gigs or something by deleting all the old generations. And that's something you also have to get your head around. Like, it's not always entirely obvious how to save space, and these things, like the best practices, are not entirely obvious sometimes. But there's reasonably good documentation for these things. Yeah. So that was basically everything I wanted to mention. One other thing I'll mention is that, which I can't really show you, but is that it works pretty fine on a touchscreen. So yeah, as I said, I normally use Wayland, and that's a pretty smooth experience. I haven't tried a pen device, but yeah, these things are interesting to experiment with. I did also want to mention, let me just see if I can, oops. Yeah, so like there are also, of course, things like if statements and being able to declare like different, yeah, there's lots of content out there. I just wanted to kind of show off that it is a functional language with like let expressions and if expressions, and just to give a very brief glimpse of it, though I wouldn't call myself an absolute expert on that yet. Although, I mean, you learn as you go. So yeah. So yeah, so that is pretty much everything I had to say. The parting comment that I have is that it is very beneficial in many ways. At the same time, though, it can be time consuming. So it does depend on whether you have the time to sort of invest in finding out and learning the language and all of the effort that goes into that. But it does pay off. So it's kind of like reasonably high investment, but I would say reasonably high reward as well. So I do encourage you to try it out. And next slide. Pardon me. Okay, and yeah, so I encourage you to check it out if you are interested, and I have a link here which has basically all the notes related to my slides. And so also nixos.org is the website to actually download it and give it a try. So thank you very much for having me, and yeah, feel free to ask any questions.
Thank you very much. Very interesting presentation. Thank you. Yeah, we actually do have some questions, Daniel. First, where should I shoot? Start here. Nix language. Hi, I think I read that Nix language is based on Haskell. Is it so?
Good question. Yeah, I think as far as I know, it's certainly a functional language, and so I think it has been influenced by Haskell. I don't know specifically if it is particularly closely related to Haskell in particular. I do know that one thing I wanted to mention was that it part of the story behind NixOS is that it did kind of come out of a PhD thesis of someone at some point, and it was kind of, that was a key factor in like making it a real possibility, which is quite interesting for an operating system to come out of a thesis. But yeah, I don't know specifically about how it relates to Haskell, but definitely as a functional language, it's related in some way.
Yep. Thanks. Next question. Did you consider using GUIX SD when choosing NixOS?
I have definitely heard of GUIX. I don't want to say anything bad about GUIX because I haven't really tried it myself. I think that NixOS broadly is, I don't know, how to, like slightly more user friendly in a way. And yeah, but yeah, so I feel like GUIX would be a bigger step to jump into than to just jump into NixOS.
Yep.
Yeah.
Next questions. A guy asking about, I guess. Thank you for your presentation. Any suggestion, guidance for configuring multiple external monitors?
Well, for me personally, I've used it with multiple external monitors without any hiccups at all. This might be because of, it might be because I use GNOME, that it works without too many hiccups. I haven't, yeah, so like at university, I have two external monitors and it just works fine, and I can rearrange them as fine. So it might just be a GNOME thing that works fine, but if you're using a different setup, sorry, I don't know myself.
No, no, that's fine. It's okay. Next question. You mentioned that that you do your configuration files in Nix language. Can you describe how you would go about writing example your .bash HRC file in Nix? Or is that little bit what you showed? You showed a bit of configuration in the end.
Yeah, I currently don't do. I think I might be able to show.
Yeah, do it.
If I have. The closest thing I have to configuring is just setting up like a few aliases. So I don't know if this quite relates, but I don't personally customize like a bash.rc file too much. This is the closest here that I come to sort of configuring anything in general with my bash. Yeah. But yeah, I'm sure there's plenty of ways to do it. So,
yes.
Yeah.
Yeah. Another question. I mean, do you think you're more productive using NixOS compared to macOS or Windows in your daily work?
I think I am now. Certainly, there were say the first month or two. It was a lot of change. A lot of that, though, was not specific to NixOS. It was also just the switch from Mac to Linux in general. But yeah, I think now I do definitely reap the benefits of being on NixOS in particular. It makes my life a lot easier, and also have a lot less, like, for example, like concern that my system is just getting out of control, and like I always know that I can put it in exactly the state I would like to.
Yes. Well, I don't have any more questions, and I don't see any more questions in the chat. So thank you very much. Very nice presentation. Thank you very much. I'll give you get an applause from me. Thank you very much.
Thank you.
Thank you, Daniel. Yes. Thank you, everyone, for watching and following us today. We will be back in approximately a month on the 15th of March. Then we run at 18 set. We currently have one presenter, so if you're interested to present or have a friend that should present something they know, you think they should present, please get in contact with me or get your friend to get in contact with me. You find me on most of the social media, so just pop over and say hi and we'll put you on stage. With that said, thank you everyone for watching tonight, and goodbye.